Hello and good morning. Today we are going to talk about something new. Before that one, 8.3. Yes. You can see there is not 10.3 because in 10.3 we have just two important things. So I'm going to mention it here because later we are going to use comparison test. Look at here. We have P or in the 10.3, just we mentioned two things. P series. Well, let me say one thing. P series. When you say P series, I thought it was in 8.8, we have 1x, 1 to infinity, 1 over xp dx. And we call that one as a xp example. Do you remember that? And we see we have three cases. P greater than 1, P equal to 1, P less than 1. In that case, we say P is what? We will get converge, diverge by diverge. Do you remember that? The same thing is true here. We don't have anything to mention here. We have just, instead of from 1 to infinity, 1 over xp dx, here change to from n from 1 to infinity, 1 over np, np. So in that, just we have n and p, nothing else. Nothing in up, nothing in down. So in that case, the same thing we say that one, p greater than 1, p equal to 1, p less than 1. Converge, diverge, diverge. Understood? Now I'm going to give you example, don't worry. So the examples like that, the examples, for example, it's a P series. For example, we say P greater than 1. Look at the example here. N from 1 to infinity, 1 over n squared, right? So not 2 to power n, no, n squared. 2 to the power n is geometric series, right? 2 to the, but n to power 2 or n squared is P series. And in that case, we say it's converge. We say by P series and P equal to 2 greater than 1 is converge. You got it there? How about for the second? How about for the second? P equal to 1. When you say P equal to 1, thank you. When you say P equal to 1, like what? And called harmonic series. Harmonic series. So harmonic series is a special case of P series. Understood? So in that case, the example, it should be like that. N from 1 to infinity. You know, P is what? The power of n is, yes. And if P less than 1, again, is that one is diverge. Usually, when I say harmonic series, do not think about it. Just say it's diverge. When P is less than 1, example like that, and from 1 to infinity, square root of n. You know, square root of n is equal to what? n1 over 2. Am I right? That's right. So in that case, we have a P series and we say diverge. So it's your turn to answer. How about that one? A. How about B? Three over 2 and 2 over 3. So you tell me about A. Converge, right? Why is 1 and point something, so it's greater than 1. Good. So it's converge. How about the second one? Diverge. Exactly. 2 over 3 is less than 1, so it will be diverge. So that's all that we need in 10.3. So we use that one. We use these two limit comparison test. Okay. We have comparison test in 10.4. We have two things. comparison test, CT, briefly, and limit comparison test, LCT. So both of them are the same, but the technique are different. So I'm going to use that one for you first, then later we will talk about what we have. So listen, here is very important because we bring the series from our pocket. We need a limit comparison test. So comparison is what? Compare something with something else, right? I have that one, it's less than that one, right? That one is shorter down. So I have one, then I'm going to compare, right? That's why. So here we are, here's the examples. Forget about these examples now. I'm going to the limit comparison test. Then later we'll talk about that one. So look at here. Here's the rule. Here's the rule. We have 3 rules. And we use also during the rules, we use the limit, right? And we have Bn. Look, you have Bn and something. So in your lecture note, he mentioned by three cases and he makes it. But now I'm going to make it at some cases for you. Okay, now we have limit comparison test. So how we deal with the limit comparison test? In the limit comparison test, you have An, you don't know, is converge or diverge. So when I say you don't know, so it means that it's not geometric series, it's not telescoping, it's not a entity, you cannot use entity. Then it's not like a direct, it's not like a P series. So we are going to compare with something. Compare that one. It looked like something, so that I'm going to compare. Okay. We have 2 parts for converge. You see that you don't know An equal to what? Converge or diverge. So you bring Bn, which you are sure that 100%, because you bring it from your pocket, 100% is converge. Understood? You bring someone in your pocket, in your mind, then you put it down. Okay, then the second, but you know about that one. You know about that series converge, 100%, you are sure about that. Then you are coming to compare or compute An over Bn. Understood? If the result of this limit number greater than 0, okay, or you get 0, you say what? Look, you say what? You say An is also converge. Why is also? Because we compared with B. Understood? I don't say it's converge. I say it's also, to remember that there's something we compare with that something. Okay? This is the first. And, sorry. And the other part for divergence. For divergence, LCT. Look, you bring in your pocket Bn and you are sure 100% is diverge. Then you compare again An over Bn. Again, if you got C again greater than 0 or infinity, in that case, you say what? An is also diverge. Why also? You know why. Because we have Bn before. That's why we say is also. Okay, dear? Just that's a rule. Don't worry. Later, I have a note. I will give you a note when I review that one for you. So we have a note about infinity and zero. Later, I'll tell you how to change it, how to check yourself that you make a mistake. Okay, we are going to the example. Forget about the proof as usual. We have that example. 2n plus 1. I'm going to the new page. Series of 2n plus 1 over n squared 2n plus 1. Okay. So, yalla. How we check? It's an exam. And I gave you many, for example, 10 series. I say, fine, I converge or diverge. I don't see this with that one. You should find and distinguish them. So tell me, is it geometric series? Do you think that one is geometric series? Put the number n1, n2, n3. N1 to infinity, yalla. Do you think that one geometric series? No. Is no, because the geometric series, there's R and there's no R. If I put n1, I will get 3 over 4. And again, next, and look at, there is no R. So it's not geometric series. In my mind, this is not geometric series. And I told you, before geometric series, you should think about what? NTT, right? So take a limit by NTT. Take a limit. Limit of n, that one is happening in my mind before answering. 2n over n squared. I know is equal to what? Say 0, right? Denominator is greater. And we say entity with a 0 is failure, cannot test. So it's not good. And I think that one cannot be into two things. I cannot change it to A and B. Telescoping. It's not telescoping. The telescopic form is not like that. I cannot take the 2 and get the minus. Okay, so it's not telescoping again. So it's a P series, the fourth one that today you got it. Of course, no, it's not like that. Am I right? It's not like that, but it looked like that. It look how? If I bring the highest degree, if I take a highest degree of the numerator, I'll get 2. And how about denominator? N squared. And I know that one will be what? Right? And if I bring that one to out, I'll get what? It looks like P series, right? 1 over n is P series, it's harmonic series. Am I right? Was harmonic because we say if P equal to 1, we rename it as a harmonic, and it's a diverge as usual, you know. So we get what? After thinking, there is no way to solve, right? There's no geometry, no power, no entity, no telescoping. It's not. It look like P series. So that's why I say I'm going to solve by LCT. How? I say by LCT. How? By LCT. First, I say let Bn you know, we're bringing that one from our pocket. We bring it, but after doing some algebraic things. We count the highest here and highest of here. That's how we get Bn. Usually, it's look like that. I don't say 100%, but not. Mostly it's like that. Do you have any question about Bn? Hello? Okay. So Bn, tell me, you know, you bring it. Tell me it's converge or diverge? 100% you know about that one, right? Is divert. What was about the second step? The second step say what? No, compare, yeah, you're right. AN over BN. So is equal to limit n approach to infinity. AN is equal to what? Am I right? BN equal to what? So I'm expecting to get what? Number greater than 0 or no. For divergence is infinity. Second part, okay? For convergence, you are right. C or 0. For divergence, again, C or infinity. Good. So how we solve that question? How we solve that limit? Easy. IC is equal to limit n approach to infinity. The first part, am I right? Easy. Equal to what? It's equal to 2. Greater than 0 or not? So by LCT, our series A is what? You got it? You have a series. We cannot solve by the previous one. So I'm going from that series. I'll get a new series, so Bn, and I'll see converge or diverge. Then I'm going to use the limit and divide them. Then I'll get the result. If the result infinity or greater than any number greater than 0, that means a positive number, I say is diverge. If I bring the converge Bn, the result is 0 or greater than again 0, so I say what is converge. Now you understand something. Not vertical asymptotic. Yes, yes. And Jami limit here, the result of the limit. I don't know. Maybe that one is ln. I don't know. Yes. Yes. Yes, sir. Silent, please. Silent. Okay. No, change. We have many things. So we are dealing with it. This is the first one. Yalla. Question. Problem. Say it's okay. Ask. No, zeker. Do case man here. We have two cases. Zeker wel. We have two cases in the LCT. Okay. Bn converge. Bn diverge. Okay. Understood? باشا واضحة؟ Okay. أما دي An over Bn ورقدي the same thing is here. An over Bn طبعا n approach to infinity, n approach to infinity. That's it. Result here, the result of here, because Bn is converged, may be 0 or c greater than 0. The result of here, infinity or the c greater than 0. Both are the same. Maybe you ask how we distinguish them. That's a note I say I will tell you later. So for now, just depends, or our mind, our key is what is Bn. Bn is a remarkable series, really, because if you don't know how to bring it, you don't know the results which one, right? So Bn is converge. I'm waiting for, after taking the limit, I'm waiting for what? Getting positive or 0. If Bn is diverge, I'm waiting for infinity or positive number. That's it. Understood, Kaka? This is the share, the same, but with a different Bn. Why? I didn't say this one in the middle. That's why I say I'm going to expand, sorry, Yes.
This one is what?
C, constant. That's why we say that. We say, I distinguish with your lecture book notes. Why? Because he make this one, the C in one cases. He say if C greater than 0, A and B and both converge or diverge. So you mix them. But now we distinguish between them. You know, we have 2 cases or 4 cases. If my B and is converge, I'm waiting for to get into results. If diverge, again 2 results. The result of converge 0 or positive. The result of diverge is positive or infinite. Understood? Good. So let me do a mistake. Together notes, okay? Maybe you see how we get C2 2 times is impossible. How about if I change the example that I bring, it's like that. I mix between them. So you will see the result. Use this result, you understand. Look, Kaka. Look at here. The example, previous one. 2n plus 1, n squared, 2n plus 1, right? For example, by mistake, during the exam, I say bn is equal, this one square is 1 over n squared. And you know 1 over n squared is converge or diverge? Converge, you know about that. So it's converge, don't you? In the reality, it should be diverge, but we did a mistake. It's okay. So you say what? An over bn. Isn't it in the second step? Right? This is the first step. Let me do it everything nicely for you. By mistake, let bn, which is what? 100%. When I say 100% means that you know. Okay. So this is the first step. The second step, an bn. Well, Jamaat, guys. Okay. So I'll get what? Limit 2n n squared to n plus 1 over n squared. Am I right? And the reciprocal of the second question, second fraction, you'll get what? You understand how? Reciprocal of n squared, multiply to the numerator, and you go that one, right? The result is what? But we're waiting for what? In the reality of the test. Because you bring the converge. You expect what? 0 or positive, right? But you get what? Infinity. You are waiting for C or 0, but the result it was infinite. So in that case, you should know about that. Your Bn is not good. You did a mistake. So go fix it. You don't get that other C. You understand what I say? You got it? If you choose the Bn as a mistake one, you will get some results not expect. We are expecting this or that one, but the result says something else. So it means that your Bn is not correct. There's an issue. And like a UDV, I told you, compare. If that one is harder, you should change the UDV. You should sweep them. Because that's not the same. You are checking yourself. If you get something else, means that your Bn is not correct. Go bring another Bn. So I'm going to say, oh, that one's not one. So that one is not. So that one shouldn't be converged. It should be diverse. So I should change that one to something else. Understood? Yes, ask, it's okay. Yes. I just only I solved one example for you, no more. Yes, of course. Just example, Marhaka, you get that idea. We apply the rule, that's it. Nothing else. Question. No question. Okay. Good. So here we are. We are going to the second example. Look at here. Yes. 2n minus 1, n from 1 to infinity. Yalla. Geometric series. Before anything, first test by entity. Okay. So take a limit. I told you the entity is what? Screwdriver. You remember that. So use it the first. So entity for that one equal to what? 2 infinity minus 1, right? So 2 infinity, infinity, infinity minus 1, infinity. And we get what? Entity is not working. Second, geometric series. Okay, this is geometric series. Huh? Why? The minus 1 make them something else, right? The minus 1. I got a minus 1 elaborate. Yes. If we erase minus 1, you get the geometric series. But if you put it, for example, if I put n and 1, so I'll get 2 minus 1, right? If n is 1, I'll get 2. 2 minus 1, 1. How about the second? If I put 2, 4, 3. How about the other one? 8, 7, right? So there is no R. Kata is not. That one you should do it directly for all of them. Otherwise, you don't know how to solve them. So kindly, and I know 100%, I cannot change that one to A and B. Am I right? It's just one, I cannot separate them. So it's not telescoping also. So number 4 is what? P series, right? P series. Is P series? No. P series like that. Right? Not 2 to power something. Something to power 2. We are waiting for that one. Or something to power P. So it's not like that. So how we solve the last things we are thinking about it? Yeah, we are going to use limit comparison test. So you just think about it and we review all things, 10.2, 10.3, 10.4. You should do it like that. So I have that one. If I take that one over that one, I'll get what? You got it? So in my opinion, that one is Bn. It's converge or diverge? طيب 1 تسبيح جار و2 معنا يك تسبيح 100 1 times we say that. It's geometric series R equal to 1 over 2. Of course, 100% is what? Converge, right? Understood? Good. So from the next week, your participating is be like that. I'm asking you, it's converge or diverge. If you answer. You don't answer, you lose your grades. So kindly use some revision, do something, study well. Okay, so we have what? We have converge. So now my question is like that. And we bring a B in to be like that. Sorry. Which 100% converge. So I'm going to use limit n, second step, right? An over Bn was equal to am I right? And how we solve that one? Infinite over infinite. So what? Indeterminate. So how we solve indeterminate type 1? By l'orbital. So I'll get what? Derivative of numerator, right? Over Derivative of denominator. Understood? Derivative of that one is equal to what? Huh? Equal to what? You solve it by something else. Okay. That's solved by something else. Later I'll tell you. Derivative I to power u. Derivative is equal to what? Yalla, call one. Itself u prime, sorry, ln of base u prime, right? Understood? Hello? Good. So derivative of 2 to power n is equal itself derivative ln of base n prime 1. Okay? How about derivative of denominator? That one the same, that one will be 0. So we get what? 1, yeah? N approach to infinity is equal to 1. Understood? So we expect to get what, Kaka? C greater than 0 or 0. Thank you. We expect here in that limit to get 0 or C greater than. So we get 1. It's good? Yes. It's C greater than 0. So it means that our series is also converse. Now you know how to bring it. Look here. Those B and that we bring them, mostly they are P series or geometric series. Okay? This one that we will bring in our pocket, they are P series or geometric series. 98% are geometric series, P series, sorry. Because most of the example need 1 over n, 1 over n squared, 1 over square root of n. Understood? You got now? It's a little bit clear, right? Bn, how to bring Bn. I'm thinking about Bn, about the 2B P series, mostly. But there's some cases like that. Look, shouting that geometric series, shouting that bring the geometric series. How? By distinguishing like that. You got it, Jamaat? And the third example. Where's the third example? C. 1 plus n plus ln of n. Over n squared plus 5. So how we bring the Bn? Tawan is not geometric, is not entity. Let me solve by entity at least. Entity will be infinity, multiply infinity, and that one will be what? Huh? Because that one is n, that one is square, so you'll get what? Infinity again, but that infinity is square, that one is n. If we divide by n, we get what? Hello? We get 0, right? You know why? Look, we divide by n square, n square, n square, and n square. That one will be 0. That one will be 0 again. That one will be 1, 0. So I'll get 0 plus 0, 1 plus 0. I get 0 over 1 is equal to 0. So it's not NTT. It's not NTT. So it's not, of course, 100% is not telescoping, it's not geometry, because there's no number to repeat it, right? So I should go to the LCT. Am I right? So how I get Bn in here? Yes, right? So is equal to what, Bn? Diverge or converge? Harmonic. Diverge, am I right? Okay. So compare. And will be changed to what? Am I right? And that one equal to what? Hello? Equal to 1? Do you think so? I don't know. Equal to what? Divide. I'll get what? Am I right? Hello, Jamaat. Divide by n squared. 1 over n. Just ln of n. 1, 5 over n squared. So take a limit. 0 plus infinity. 1 plus 0 is equal to infinity. Did you expect to get infinity? Huh? Why no? Even you can say I don't know, because as I don't know, I'm going back to Bn. So Bn is what? Diverse. So yes, I am waiting for C or infinity. Why not? So you get infinity. So S also diverge. Now you understand how to play with it, right? If you forget, go check Bn. You know. So Bn depends is key of the work. Okay. We got what's So how we solve that limit? Let me homework. Think about that as another way. Instead of taking it's easiest way actually. Instead of taking the derivative, okay? So how? Can you tell me about this is the what? Yes, divide to n, you're right. Divide by 2n, you'll get 1, you'll get 1, you'll get that one, and limit of here is equal to 0, then you get that one. It's easier. Okay, now we got what here? You can see is what is infinity, our example. Good. So does that one converge or diverge? Homework. You don't need to, you just look at and see how we bring the Bn. Look, y is 1 over 4. Think about it. Okay. Do you have any question? This homework. If you try to answer this homework, I'll give you 2 more homework to answer that one. You understand? To answer this homework, you need 2 more homework. How? Go to the exercises. Number 60, I think. Here's. Okay. Just let me see. No, sorry, not that one. '63 and '62. And read it. Just read that one. Make this rule to answer example 3 as well. You can, by using 63 and 64, you can answer 67 till 72. This is the key. So let me give you the clue about the 63 and 64. Just read it for me and let me give a conclusion. Yalla. Read and give me the conclusion. Clear, right? Now, show that. Let me say we have what? Ln of Q, N of P, P between Q between infinity and minus infinity, and P greater than 1. Hence, limit comparison or limit LCT with ln 1 of NR, where R between 1 and P. What do you mean by that? Isn't hard? Do you think it's hard? Yes. Line by line, yalla.
So you're going to have it.
Anything. It's okay.
So the first one shows that it is converged only when Q is between minus 1 and infinity. So it means that P is obviously greater than 1, but هنتكي أولا على R جبيني لو يبدو لترى طبعا كيفش.
Okay, so what's the difference between 63 and 64? Yes. Exactly. Thank you. We're close to get the point. Look at here. Look, here, n, of course, I told you I n from 2 because you have len, right? Then shouldn't start with a 1 or 0 is undefined. At 1 we get 0, so that's why. So here we start with the 2. So okay. Now we say Q between infinite or minus infinite. What do you mean by that? No. All real numbers. Q is any real numbers. Any real numbers. Understood? Q, we don't, depends on the Q. So both cases you can see. In both cases, Q does not matter. It's 2 power 1, 2 power 3, 2 power 10. We don't care about Q. You got it first? Hello? This is the Q. Okay. Like that. Second example. Then, if P greater than 1, so if I have a len with a P, with NP, if P is greater than 1, bring Bn. This is the Bn. By what condition? That one is greater than, yes. So P is greater than 1. P is 2. Greater than 1. Okay, good. So bring, you see that, to find the comparison test, to solve by comparison test, your Bn should be 1 over NR. 1 over NR. When R between what and what? Greater than 1, less than P, sorry, not infinity, P. What do you mean by that? Means that this N should be like that. So my P is 2. So R should be between 2 and 1. Am I right? So R is like what? 1.5. Or 1.9. Am I right? So I'm going to use what? 3 over 2. Why? Because I know 3 over 2 is what? 1. So for solving such example like that, for example, during the exam, if I gave you len of n over n to power 3, your Bn, it should be what? Yalla day. Between here, between 3 and 1. So I'm going to use 1 over 2. You got it? or you can say 1 over 2.5. But easy, use the integer number is better if you can. If you can't, use the large fraction, like a half, 1.5. You got it or not, Jamaat? If you don't understand, kindly raise your hands. Really? Good. So solve that one for me. Yalla. Narrow. It's my question. Do not see. That one? That one? Here? Here's the example. Yes, it's the example. Or persiarage. Shinaga persiarage. That's why piece 2. You got it? Okay. Now answer that one for me, please. Ln to power 5. Ln to power 5. And what? Yeah. And n to power. Yalla. It's converge or diverge? So give me Bn. Yalla. See? Where's P? P is equal to what? P is 3 over 2. So I should bring R between what? Am I right? So is what? Two. 1 over 2. Why no? No, 1 over 2 is less than 1. That's why no. You know? Oh, you got it or not? Got it. Okay. So what else? Up to you, yes. Why not? Yes, why not? That one is 105, right? Bring what? You got it? Understood? Why you don't raise your hand if you don't understand? So now that's it. Okay, Jamaat? You can say 1 over 4, 1 over 25, up to you. If you like, use 1 to 25, between 1 over 15, 1 over 0, 0, right? So between 1 and between 150, I'm going to use what? Up to you, or 4. You got it or not? Good. So my Bn is like that. Easy? Whatever. Maybe you choose 1 over 25, like that. This is about 63, yes. Yes. Whitman Q إهمالك. Q إهمالك. إيش يعمل سيرشيا? Depends on P. John, sorry. Listen to me. We have ln of Q n of P, right? And we need Bn silent and R. We have 3 things. Q, P, R. Forget about Q. You're focused on P. In 63, if P greater than 1, bring R. When R is what? R between P and 1. That's it. And you should get convergence. No way. Understood? Yalla di. Ln of 5 فرمو. N to power 3 over 2. We have no x here. We have P series, no x. Okay? You mean x here? No, we don't care about x. X is like a number, constant. Now, this example, this is Q. And that one is P, right? So P is what? 3 over 2, greater than 1, yes, it's 63. So I'm going to find R here. That's your duty. For example, you say 1.4, we say that, right? So your duty is what? To say we have a Bn 1 over n.4 then I'm going to this 100% converge. So I'm going to use L and P over, that's it. We don't care about the len. We don't care. No, no. Your example is what? Len of and n to power 2? Wait, 4 or? Okay. So there is no dwai. We are solving now. Okay, listen. This is Q. I don't care about it. This is P. Good. P is equal to 4. Greater than 1. I'm going to use 63. You know? Okay. So I say what? I say between 4 and 1. I'm going to find R. Up to you. 2, 3, whatever. 2. Okay. So now I say let Bn 1 over n squared. 100%, you know, is converge. You got it? And go divide it. Second step, divide. Question. Okay, 64. 64 say what? The same. You have L, Q, N, P. But this time P is what? Unfortunately is less than 1. Yani, yes. So it's diverge. So how we choose divergence? You say what? You say 64. We have P, Q, Q whatever, and P is what? Between 0 and 1. Means that ratio, half, like a square root. So limit compares and for P series. So bring a P series with not converge. Less than that. Understood? Like that. So use these two, okay, to solve these all together. N4. N 1 over 2 here. N greater than 1 by something, right? So 63, that one. 63. 64. How about that one? You know what I mean. And go on. Okay, Kaka? P is and a Q here is what? Q. Huh? Q. Q the power of len is what? No, it's -3. Right? Can bring it to up. Right? So Q any number. We don't care about that one. So is P 63 or 64? 63, 1.1. That's fine. Again, give me the key, here. Right? Now you got everything. So think about it. So that's why I said that this example is what? Example number 3. Depend on what? Now you know what I mean, right? Now you can solve that homework. Am I right? So we answered that homework by two homeworks. Because you have a rule, we know how to get it, and that's the result. So now if you solve that one, you understand how we get that one, and that's all we need to cover here. Question?